All right, we'll give it a minute and we'll get started. At this point, we should be live on LinkedIn. Let me just bring up my screen. Hello, everyone. It's 9 a.m. Pacific. Good morning, good afternoon, good evening, depending on where you're joining. I'm sure everybody is sick and tired of hearing about the banking fiascos here in the Valley. And so we're excited to talk about a more refreshed topic around open source software. And I'm joined today with two amazing speakers and leaders from the technology and security side, who Aman and Chris, who I will let introduce themselves, but maybe I'll just kick it off. So my name is Varun Badwar. I'm the founder and CEO of Endor Labs, and been in the entrepreneurial journey of cybersecurity product building for the last 13 years or so. Prior to this, created a company called Redlock that you may now know of as Prisma Cloud. So excited to talk about our perspectives on open source software security and governance, more from kind of a product development standpoint. Aman, maybe I'll turn it over to you. You're next on this page. Tell us who you are and what you do. Welcome here.
Thanks very much for having me. I'm Aman Pind. I'm the Global Chief Architect for State Street and the Chief Technology Officer for State Street Digital Assets. I've been with the firm for 4.5 years, and just like yourself, I have my own entrepreneur background as well. I was the co-founder and CTO of BestX, and prior to that, I've worked at Morgan Stanley in New York, Lehman Brothers in Tokyo, and Adobe and Fidelity as well. So very nice to meet you all.
Great. We're very excited to have you here and hear about your perspectives more from kind of the technology side. And speaking of that, we have a counterparty to balance us all, which is Chris from a CISO background. Chris, thanks for being here.
Yeah, definitely. I'm excited to be here. Chris Hughes, I've been in the cyberspace almost 20 years. A lot of that time spent in the public sector, active duty military with the Air Force. I've also worked with the Navy, the Space Force, the FedRAMP team, and then various commercial entities that I've worked with as well in cybersecurity. Spending a lot of time the last several years around cloud, DevSecOps, and software supply chain. I'm also the co-author of a book called Software Transparency that's out in June from Wiley, focusing on open source software, software supply chain security, and all the topics we'll be touching on today.
Amazing, amazing. Great to have you both. Well, I figured before we kind of dive into the Q&A session and dialogue, I think it would be good to level set on, why is this even a problem today? And so, I have a couple slides just covering that. First and foremost, let's all agree that there is more code in modern applications that we don't write, but borrow from the internet than there is first-party code. And in essence, what we find is most software engineering teams are starting to shape up a lot like software assembly teams, not to take credit away from the work they do, but it is a lot about reuse of existing software. And with over 47 million open source software packages and versions available, 3 trillion downloads, it's clear open source is here to stay. It's won the hearts and minds of developers. And what I like to think about it is it's Disneyland for software developers, except nothing in this world is free. And so as you start stacking up lots and lots and lots of open source software, it is really, really important to think about the implications of that. And sharing here some screenshots of various conversations on social media from key leaders in the space like Kelsey Hightower and other names that might be very familiar to you, complaining about all these transitive dependencies that get pulled in, why people should have a dependency removal engineer in their companies, how painful dealing with conflicts is. And by the way, this is just a developer perspective. If we had a screen like that about the security complaints, that could take up another hour of just looking through. So what we're going to be really covering today in this interactive discussion, and we would love to have the audience engage and send us questions that we'll take live as well, is really around the role that open source software plays today. What should be the things security and development teams should be thinking about? How does this process of using open source work in large enterprises today? Who owns it? Who downloads it? Who's responsible for maintaining it? And ultimately, all of the AppSec challenges with the programs, with tools like software composition analysis, and hopefully towards the end, a lot more practical advice to the practitioners and technology leaders around this topic. But if you bear with me for 2 more minutes, I think it's really important to kind of level set everyone on some key topics we'll touch or principles we'll touch. First and foremost, when we think about open source, it is super important to understand that there are direct dependencies, which are the things that your developers mean to actually download from the internet to use in their applications. But what's really important underneath that is that for every one direct dependency that a developer downloads from the internet, from the open source ecosystem, on average, it brings in 77 transitive dependencies. So you'll hear this term come up, direct dependencies, transitive dependencies. Just be mindful of that. And in fact, what studies have found is 95% of security vulnerabilities tend to be in these transitive dependencies that we're not paying a lot of attention to. The second thing I just want to call out is that we recently published a report, which is peer-reviewed by over 30 CISOs and technology leaders, talking about these top 10 open source risks. And what's important is these are not just security risks. These are security risks as well as risks to the operations, to the resiliency of applications, and the reliability of the software you ship. We will not go through all 10 of these. We'll have a separate webinar on that in the coming weeks. But my colleague here will send a link to everyone here who's interested in downloading this report. And why that becomes important, the last piece I want to touch and then open it up for the discussion, is we have recently seen lots of different incidents in the open source ecosystem connected with these types of issues. For example, PyTorch, which is one of the most popular machine learning open source packages available that is actually sponsored and managed by none other than Meta, got compromised between Christmas and New Year through OSS risk 2, which is compromise of the legitimate package. There was Sentinel-1, which had a different type of attack, which was a name confusion attack to their SDK. And the last one is really kind of pointing to the risks of unmaintained software, where core.js, which is at the heart of every web application on the internet, is maintained by a single individual in Russia who was imprisoned for 10 months, is in financial duress, pleading to the internet to kind of save him, his life, his earnings, but is used by Netflix, by Amazon, by Google, pretty much any web property out in the world. So that's just how much core reliance we have on open source. And I think that tees up the conversation now well into some of the things I want to talk about with Aman and Chris. So I'll stop sharing my screen so we can see everybody and have an interactive discussion. But maybe turning this over to Aman, you first, being in a technology leadership position at a very large enterprise, regulated enterprise, what do you think, what is the role open source software plays today as you think about kind of application modernization and cloud migration and just new app development?
So I think what you said earlier with regards to the role of developers evolving into assemblers rather than coders, I think you're absolutely right. Just because now what we are moving towards is a higher level programming language where most of the libraries are either inbuilt or open source. And the true skill is to actually understand the business use cases and then leverage everything that is currently there, just like building blocks from a Lego, and build whatever is needed. But what we need to ensure is that as these developers, they build these Lego blocks, we need to make sure that how are those blocks being chosen, how secure they are, how reliable they are, because if we choose just one wrong block, it can bring the entire thing down. So open source is very, very key in order to maintain the agility that we need in order to be able to quickly address the market needs. But it is also very important for us to stay on top of the security and risks that it can create.
Great. And I'm going to double click on that in a few minutes, but Chris, I want to bring you in here. There's this fascinating thing around when we think about software supply chain security, we talk about open source software as a key part of that. But I'm just always nervous that we use suppliers as a terminology for open source developers. Can you talk more about this? Are they suppliers? Should they be considered suppliers? And what's their role in this versus a consumer of open source?
Yeah, actually, I don't think they are a supplier, and many of them, overwhelmingly, the majority of them don't view themselves as a supplier. There's actually a great article out there titled "I Am Not a Supplier" by a very popular open source software contributor, where he kind of lays out that there's no contractual relationship between him and your organization. He put the software out there as is to, be used by the community, but he's not beholden to any request from you in terms of responsiveness or fixing any concerns or vulnerabilities that you may find in the code, for example. So I think organizations consuming this need to understand they're using it as is, and the supplier, the open source software maintainer, and is more appropriate to call them. You can't make requests or demands of them. Obviously many of them are great and they want to respond to the demands of the industry, address vulnerabilities and be responsive and have a thriving project. But you can't force them to do anything, and you need to be in a position as an organization to even potentially fork the code, take ownership of a fork of the code, apply a virtual patch, address a vulnerability that you need to address that they may not be addressing quickly enough for you. So I think kind of discussing open source maintainers as suppliers is a misnomer that we need to correct as an industry.
Got it.
And I think that is perhaps the reason why. So within the industry, there is now many companies and enterprises which are actually taking ownership of open source packages. So for example, I work with Julia, and they pick the top 25 most used Julia packages. And if you buy an enterprise license, they commit to manage those programs for you, which is precisely, for example, the MongoDB model, the Databricks on Spark model, and so on. So, and that is something which is bringing more like security and safety back to the enterprises, and is almost becoming a mandate, which is why these companies are doing so well.
So let's touch on that a little bit more, because I always find it very fascinating, right? You have these companies that are really supporting the ecosystem, but if you look at it statistically, that's maybe 5 or 10% of the open source software. The 95% of the open source software is the guy or gal in the garage spending a couple hours a week. 4j, great example, right? Or Log4j. These are the things ultimately that bite us in the backside when issues happen. So Aman, there's the stuff you can get where you can buy support and you can pay a company to help you with. What do you do about the rest of this stuff as an engineering organization? What is the directive, you think engineers have? Do you start forking stuff and owning and maintaining it yourself? But then not everybody's Google. You just don't have the resources to do that. So how do you kind of pragmatically approach this in an enterprise with all of this long tail of, just mom and pop shop developed stuff?
It is a challenge, and I don't think forking is necessarily an option just because of all the transitive dependencies. Because if you pick one library, then what you do with the other 77 that you are actually implicitly onboarding? Do you fork them as well? Do you have the ability to be able to manage them? And if we started thinking about it this way, then the very premise because of which instead of writing that code, we are relying on open source libraries, that itself falls apart. So what we need to do is make sure that there is a framework through which we can pick these libraries and stand behind them. So for example, within State Street, what we've done is we've instituted certain rules that if you are bringing in certain libraries, then they need to have a minimum number of contributors. The code base cannot be such that there has been no check-in over the last 6 months. There has to be no outstanding CVE, and the turnaround and SLAs of any CVE that was previously reported should be like a day or a week or a month, depending upon the severity. So what we need to do is, so we try to look at all of those libraries and try to get them through this litmus test in order to confirm whether there is something that we can or cannot bring. But of course, this is a governance which needed to be set up here within the firm in order to ensure that we use these securely and safely.
So I want to double click on that, because that's a segue to my next question, which is how do organizations actually carefully select and curate what they want to use? And I'll share my perspectives of how I've seen the industry evolve. And then I want to hear from you how you automate this, or maybe do this at scale, at State Street scale. So 10 years ago, most organizations, large enterprises, regulated anyway, were blocking GitHub access. Like you couldn't even go out to the internet to get open source. And I think you figured out that you were just completely shutting down innovation in your environment. So then people went to what I call the next generation of this, which was, okay, we'll create a mirror. We'll use something like a JFrog Artifactory or Nexus from Sonatype, and we'll curate 500, 700 packages, put them there, and you could use anything from there. But if you want something that's not in there, you log a ticket and you wait, and that wait could be days, weeks, or months in some cases. And the other part that most people were struggling with is, again, the Disneyland problem, right? Your developers want the newest, coolest stuff. The things that are sitting in the inventory are stale now, a week after you've created that inventory painstakingly. So I want to hear from you, and then I'll go to Chris on this as well. But how have you scaled this process, right? It on paper, it sounds great. How do you do this with hundreds of thousands of dependencies, and whose responsibility is it? What role does security play, and what role do the development teams play?
So in terms of the roles, this is a joint effort across the board amongst the entire technology leadership. So, for example, within State Street, the CISO would set the guidelines, and architecture would set the template, which would adhere to those guidelines. And then the development community would follow that template of usage. And then within legal, they have the burden of proof that all the licensing requirements have been met for them to go online and to production. So the key thing here is automation. So you can bring in more packages, but the only way to be able to do that is if you have the ability to be able to automate both bringing in these packages, curating these packages, testing them against your own software licensing requirements, and making sure that there is a feedback loop in order to ensure that when the applications go live in production, if, for example, they need credits, then those credits have been provided, and so on. So automation is key, and this is effectively what we've done. So we've got curated packages, and we have a request response procedure for getting additional packages into those list of curated packages that we support within the firm. But the only way to be able to have a better turnaround time there is automation, which is something that we're actively working on.
Great. Chris, let's, you kind of talked to a lot of folks in your role, and you've been authoring your book. You've been trying to understand how people are solving these problems. What have you come across that's interesting, right? I always say there's a Google way, and then there's the 99% of the enterprise that doesn't have the resources to do it the Google way. So tell us, kind of, what have you seen in the spectrum of different governance aspects here?
Yeah, I think you framed it perfectly, and we talked about this with the whole forking comment. It's like if you're a robust organization with incredible, engineering resources and depth, it's one thing to take on projects and maintain them and fork them and so on, but that's not the majority of the ecosystem. And then, as we talked about, there's growth of crowdsourcing or funding models for major projects that are getting adoption. But as you talked about, I found some studies basically showing that 25% of projects only have one maintainer or contributor, 94% have less than 10. So majority of these projects just don't have robust maintainers and contributors. So organizations do need to implement governance to understand what they're consuming. And we're seeing guidance from groups like NIST, and Microsoft has their S2C2F framework that got donated to OpenSSF, for example. And they are talking about trying to mirror and do internal repositories of approved packages and things like that. But as you point out, doing that at scale, without imposing friction and imposing friction on developer velocity and impeding them is very tough. And I think Aman's spot on. You got to have automation. And we're seeing organizations now start to look to emerging tools and vendors and solutions to enable them, kind of that developer-enabled security model where you can bring that information closer to the developer in the workflow, let them make those risk-informed decisions as they're creating and compiling and composing software is kind of the direction I think the industry is heading in, and organizations that are ahead of the curve are starting to adopt some of those emerging technologies and vendors.
Yeah, great point. So I'll give you kind of our Endor Labs perspective, and a lot of this comes as learning from me having run a 400-person engineering team at Prisma Cloud and figuring out how to do this at scale. We think the problem is there's some vanity metrics that a lot of developers are accustomed to looking at as a proxy to popularity. They look at GitHub stars on a project. As it turns out in my research, you could go buy 1,000 stars for $64 these days. That's kind of crazy. And so really the question became, and actually a customer of ours characterized this well, what we really need is a Carfax report for open source. Like, we really need to understand the background of the human risk involved. Who are these people? What are their motivations? How good is their code quality? How good is the supportability of the community? When you touched on the SLAs of remediation, like, how can you automate bringing this data? Because technically the data exists. If you look at the GitHub repositories, they're public. The code is public. Now, what you really need is internet scale systems to do this with 47 million packages and versions and fast growing, and look at a variety of risks. And I think the problem that I see in a lot of conversation I have on this topic is most people are fixated on just two risks, which is license risk and vulnerability risk. And I think what the world needs to kind of grasp is, again, going back to there's many other ways. I gave you examples at the beginning of this, of recent incidents that had nothing to do with CVEs, that had nothing to do with license compliance issues. So how do we as an industry start thinking about the maturity of software, the maintenance record of the software? If the software repository is archived, probably not a good idea to keep using it. Or if you're 17 releases and 4 years behind, how do you detect that once you start using it? Which is kind of my next topic I want to get to with you all. Is there's an aspect of what review and diligence do you do upfront, and you touched on that. Then there's we started using it. It's a bit of a set it and forget it, because until something is broken, sadly, nobody's going back and proactively reviewing all of the open source components in your environment. And as I say, there's no customer success team you receive with open source that's telling you, we're going to be end of lifing this piece of code, so please upgrade. So maybe Aman, back to you from a technology leader perspective first. How does one think about the problem post the initial assessment? So it's there, now it's being used, buried somewhere 7 layers deep in your application. Let's take Gorilla. It was a very popular Golang package that in December, out of left field, the maintainer said, we're actually archiving this repository. We're no longer supporting it. How does one discover that? When you have hundreds of thousands of these things, and if we don't today, how relevant is a risk like that to you?
So it is extremely relevant because, just like you said, they come entirely left field. And it is extremely important for us to, no matter when an application was developed or a library was imported, to always have a running repository of all the open source libraries within the firm, which applications use them, what are the servers that these applications are deployed, what are the services that they are using, what the firewall rules are on all of the servers and premises where this is deployed. Until and unless we have a mechanism of staying on top of all of that, then things like Log4j would just completely leave you vulnerable. So what this means is that we cannot just do a fire and forget, create an application based on top of open source technologies, deploy it, and then forget about it. So we need continuous governance, continuous reporting, and a repository which through automation needs to be kept alive and online all the time for us to be able to continue to use this in a responsible manner.
Yeah, interesting. Chris, anything to add there? Otherwise, I want to kind of shift to another security specific question for you after that.
No, I just would add that I think he's spot on, and I liked how you opened this up in terms of, we all hyper focus on CVEs, which are kind of lagging indicators of risk. At that point, there's already a risk, and you're already in trouble. Where there's a lot of leading indicators of risk around these projects and their hygiene that organizations simply don't pay attention to. And then, as Aman points out, we got to move towards not just initial review and set it and forget it, but we got to move towards continuous monitoring and governance of understanding what we have, where it is, the hygiene of the projects, and the vulnerability posture, and et cetera. So I think we're definitely heading in that direction as an industry, but it's going to take quite a while to get there without the right tools.
Yep, agreed. So let's maybe shift to the whole AppSec versus dev teams. There's clearly, we've noticed this everywhere, right? There's a lot of tension, and part of the friction is, I always believe it starts with goaling and KPIs. Like, the developers tasked with move fast, build an application and features that are innovative and with speed and quality. The security team is coming in from a risk management perspective. Their goals are not around speed necessarily. Now, some organizations are starting to measure kind of how you actually enable businesses, not just impair businesses. But traditionally, there's also been a lot of tension related to the tooling choices made by AppSec teams. So, Chris, maybe I'll start with you on this one. What are the challenges you see with AppSec programs today and their approach to open source software, as well as just the current tooling that organizations are grappling with?
Yeah, I think you kind of led into it there as you talked about, that traditional dichotomy where we always hear like security is everyone's job, but when it comes to people, how people are evaluated and incentivized, developers are based around speed, development, new code written, et cetera. Security is more around vulnerabilities and risk management, and that imposes friction to some extent. So I think what I've seen so far is, there tends to be some friction between the two teams if the AppSec team, if the security team is not bringing tooling that can integrate with the developer's workflow, the ways that they currently work, and enable them to make decisions without having this out-of-band manual process that really slows things down. That's what kind of leads to that tension. So I think that's as we move forward, we're going to need AppSec teams to think about how do we kind of a developer-centric security model here. How do we implement that to enable developers to make the right decisions without totally impeding their workflow?
Yeah. Aman, over to you. I mean, how is your relationship as it relates to open source software governance with AppSec teams? Remember, this is on the record, so share share what you can.
It's extremely peachy, as one would expect. But the thing is, actually, that is entirely true. And the reason behind that is now it has become very, very obvious that, just like Chris, you said, that risk is everyone's role. And effectively, what used to happen was like almost 10 years ago, there was this impetus of trying to deliver things quickly, and efficiently. And then cybersecurity was considered to be a blocker in order for the teams to be able to pursue. But at that time, we did not have as much cybersecurity risk as there is now. So the number of CVEs that are being reported, the number of the cyber attacks that are now coming up, the rise of ransomware. So effectively now what has happened is any single time any of those things happen, then it is now the developer's responsibility to actually go back and mitigate. So effectively what that means is this increased cybersecurity risk that we have experienced over the last few years. What that has done is that has changed the developer's mindset to be more focused on security, more focused on risk at the time of development itself. And hence the CISO organization and the development organizations, they've really come close because now it has become a joint effort rather than someone else's problem.
Yep. I agree with all of that. I think fundamentally, though, the tools don't seem to have caught up with where organizations want to be. So I think the desired state is very clear. I'll kind of give an example, and I'll loop in some questions from the audience here. So, Arunish talked about, in addition to severity of CVE, context is also key for remediation. And let's touch on this, right? I think for a large organization, typically, if you're running an SCA tool today, you're getting 500,000 to 1 million alerts around known vulnerabilities in the packages you use. Now, unfortunately, these tools will look at the outside in factors, but miss entirely the inside out factor for prioritization. So allow me to explain. The way these scanning tools work is they will look at your manifest of what packages you're importing and basically assume you're using 100% of that code and tell you every vulnerability that exists in every line of code in those package versions. In reality, your developers are probably using like 10 to 20% of the code within those libraries from the open source ecosystem, but they don't have that understanding. So prioritization to me, and in conversations we've had, like, okay, how do you go from a list of 500,000 to 1 million to even like 10,000, 20,000, 30,000? We're still talking big numbers, but at least something you can start absorbing. And I think the issue has been none of the current tools used in these AppSec programs actually understand how your developers are using these libraries and what parts of the code they actually use and what parts they don't. Common in these situations, what happens is the security alerts go to the development team. The development team is then guilty until they can prove themselves innocent in return of saying, well, I've looked at my code, I've spent several hours, here's actually the reason why I need an exception. And you're almost dealing with this inversely, where in reality, the tool should do that work for you and say, here's the evidence of guilt, here's how this vulnerability is actually getting invoked in your call path, in your code, please fix it. And so we think, the developer efficiency part is something that we really need to focus on in the AppSec programs, because if you're just throwing work, not only are you getting discredited and there's this kind of distrust forming, but you're also just taking away tons of cycles that could be formed on feature development. So, I mean, have you had that experience? I'll put it over to both of you, whoever wants to start. Like, have you faced these situations, and any kind of thoughts and opinions on this?
Yeah, I'll jump in real quick. I really like, what you're pointing out here is that as an industry, we've lacked context. We kind of just do these high level, broad brush tooling implementations that produce tons of findings with no context around actual exploitability or use within the code, for example. So I think, trying to provide that context around exploitability within the code path or actually being invoked by the application, as well as looking at the CVEs and seeing, starting to enrich them with other things like EPSS, for example, exploitability prediction scoring system from first, to see like, yes, there's a CVE, but it's it's not actually exploitable, or it's highly unlikely that it will be exploitable. So I think we're seeing tooling move in the direction of start trying to provide that context to aid prioritization. But as you said, I typically have seen that not done so well so far, and what that leads to is quite a bit of friction, because the developers basically are left with this laundry list of things that they need to go and justify and explain away, and it really slows them down, causes a lot of toil and frustration on their end, and just impedes the relationship and trust, as you said, between developers and security.
Yeah,
you're absolutely right. There is definitely a gap in the industry with regards to advanced tooling that allows you to do precisely this, which is bringing in context, because otherwise two things happen. So if the code was forked and a CVE has been found, and now there is a new version, and now if you have to merge your code base, it becomes quite a challenging problem. And if you don't have that capability, then you try to get an exception. And anytime these exceptions come up, then usually the context is that instead of trying to go out and fix the problem, what we do is we try to fix the parameter, and we say that because this is not external facing, and hence, yes, there is a CVE, but it is not exploitable, because as long as our perimeter is secure, the application is secure, even if there are certain challenges with the code base. The other thing here is that when you are trying to bring in these challenges, usually the other side of the spectrum is that, okay, you know what, let's just blindly upgrade the library. But then what that happens is, if you try to upgrade your entire code base, you have to do a brand new release every single time a new CVE gets reported. Then the churn of your production management teams, the churn with your clients, that becomes extremely high. And for these cases, if 80% of the times it's entirely unnecessary, then you are creating a lot of churn, a lot of manpower being wasted, and a lot of issues being created, because every time you churn, every time you release, there is a manual process that can go wrong. So just by adding context and making sure that that is taken care of, anytime we do these releases and make these decisions, it will be an absolute game changer for this industry.
Yeah, and this kind of brings up another point I think we should double click on, which is it's easy to tell developers, hey, you screwed up, here's the vulnerability and another vulnerability you got to fix. I think we need to have empathy to understand it's not that simple as saying, here's the PR, let's push it, because compatibility issues, hey, somebody else may be pinned to the particular version, you update yours, now you've broken something downstream. And so, it's a spider web of kind of this dependency graph that we all ultimately end up inheriting in our environments. And, one of the things we've been very focused on here at Endor is not just saying, here's a vulnerability, okay, I can prioritize it with exploitability facts. I could certainly prioritize it based on whether it's in your code path or not, but going a step further to actually help developers understand how it's being used, where else it's being used, and what would be the impact of actually performing an update. And we have plans to take it a lot further, but I just kind of feel like if I could put security tools into 3 generations of technologies, I think the first ones were like 10 years ago, which were just security tools everybody hated, but we all ran for compliance reasons. I'd say the kind of the last 5 years, people have really tried to evolve these tools to security tools that don't suck for developers. And I think our mission here at Endor Labs is, how do we take it one step further to build a security tool that actually enables developer productivity, not just by making security simpler, but actually addressing other things along the way. Can you actually help me make my application more resilient? Can you help me uncover those, the early warnings? Actually, there's a question from Kaylin around, like, how do you give warnings for things that are, okay, a package became unmaintained. The comment there is maybe GitHub should do it, maybe they should, but until they do, we need other mechanisms to do it. So that's a lot of our focus. And there was another question here that, let me just take that so we can kind of get the audience questions here as well, which is, some mature organizations have processed to legal review open source software requirements from developers. How's Endor Labs redefining this process? And I think we'll kind of broaden this question to generally, where is a lot of the evaluation done today versus where it should be? What I find, Aman and Chris, is in a lot of organizations, the developers have selected a package, they have integrated it into their code, they're now getting ready for deployment, where a lot of the current AppSec tools will then trigger alerts and say you're on the wrong version, or here's a problem or license issue. The silly analogy I give is, it's like the current tools tell you after you've been married to your partner for 5 years that you married the wrong person. It would be a lot simpler to tell you that before you went on a first date, because you'd be just easy to walk away from. And so, when we talk about shifting left, a lot of the question becomes, how do you get into your developer's selection workflow? So when they are kind of doing that NPM install or a Maven install of a new open source library, how do you intervene right there? Because that's before they're committed to it in terms of having put in that work and effort to actually integrate that code. How do you do it? And, a lot of our time here at Endor Labs has been spent on building a policy engine that allows you to kind of interface with this in 3 areas. One is IDE. So that's the first point of intervention, as I call it, when your developers are just bringing this in locally. The second point of intervention is when they're checking in the code into a source code management platform like GitHub or GitLab. Can you actually comment on the PR? Can you fail? Can you reject a pull request? And then kind of in the CI process too, when you're kind of publishing a release, can you break builds and things like that if things are not going per your policy? So I think flexibility is key. You kind of want one policy that can be enforced across multiple parts of the pipeline. Let's just look here for any other questions. One more. So organizationally, who should own the evaluation criteria for open source software? And what, in your opinion, does the ideal process look like? I know, Aman, you've talked about your process, and of course, you've given your feedback, but I'll open it up to both of you. What should an ideal evaluation process look like?
So everywhere I've been, so it's always enterprise architecture, which the developers they work with, because when we talk about enterprise architecture, they interface with cybersecurity, with infrastructure, with developers. So that becomes the lake where everyone comes to have a drink. So effectively, then what that means is having the understanding of what's happening in cyber, what are the infrastructure requirements that these packages have, and whether the usage of this tool sits well with the overall application blueprint that we want to create and maintain. And just being able to check against that blueprint and give those guidelines, and based on that, decide whether to bring in or not any of these packages within your list of your curated packages. I think that is key, and that's how we do it over here.
Yeah, I'll just say my experience is very similar to his. There's usually typically an enterprise organization or entity like an enterprise architecture group where you have kind of stakeholders or representatives from the different communities come together and try to convene on this topic. And I think it has to be that kind of symbiotic relationship where security can inform policy and process, and then we can enable via tooling like you're talking about, Varun, developers to make these decisions on a day-to-day basis, not like their developer workflow level. So it's kind of a collaboration between the entities, is in kind of in the vein of DevSecOps, for lack of a better way to put it.
Got it. Yeah, great. There's another question, which is, do we maintain a ranking system of open source software before development can pick it up? So I assume this is a little bit around Endor's capabilities. The way we work of this, again, I'll go back to the Carfax analogy. Our system, the way it works is it's processing large scale of data, evaluating the GitHub repositories, as well as the code for every version of the software being released through the package managers. And the idea is for us to actually run dozens of different checks around the human factors, the contributors, what is the ecosystem of players involved in this community, where do they work, how communicative are they, how responsive are they to issues, how quickly are pull requests being merged, how much diligence is being done, like can some stranger just put a code check in that somebody will approve, or actually code reviewing this process, how secure are their own build practices, do they have a formal CI/CD, do they have bots and automation like Dependabot supporting them to automate the release process, the quality of code, the license aspect, going beyond CVEs for security. So we look at early indicators of risk, like risky API usage. Do we see strange network calls being made outbound from these packages? Like, again, lots and lots of different dynamics to basically ultimately conclude it into a score. The score is broken down into 4 aspects: security, activity, popularity, and quality. And a customer can basically then write whitelist, blacklist, and gray list, whatever factors you want, around scores. Scores are subjective. Think of it as credit scores, like it's a number and you can build policies on numbers. Or we also expose all of the objective findings about every package. For example, you can write a policy that says, if any package has known vulnerabilities and it hasn't had a release in over 6 months, meaning the likelihood it's becoming a dormant package, the likelihood of it getting a vulnerability fix anytime soon is low, I will block it. Or, if I see something with a single contributor, single maintainer, ad hoc release mechanism, then I will trigger a further architecture review. Or if things are really great, I will automatically approve the selection of that, put it in my whitelist, and let a developer move on, cataloging, knowing where it's being used. So, that's kind of how our belief is in terms of where the industry needs to evolve in terms of evaluating risks. And I'll just flash up my screen again, because I think it's important to go back to the top 10 list and kind of conclude this discussion with maybe my favorite question for both of you, which is, of these things, if you were to pick one each, what is the one thing that keeps you up at night, where you feel like as an industry, this is a big threat, and B, we're just not doing enough about it? So maybe Chris, I'll start with you.
Yeah, I mean, it's tough because these are all very valid things, and you point out examples of incidents that have used several of these risks on the list here. But I'll say, just off the top of my head, one of the ones that jumps out to me is definitely number 6, the untracked dependencies. If you look at like our industry, for SANS or CIS, critical controls, having a software asset inventory has been a critical control for decades, right? But when it comes to open source software and our dependencies, we just haven't done that very well at scale in organizations with much rigor or consistency. So I think just getting a handle on what we're using is critical. Before you can kind of address any of these other things, you have to know what you have.
Chris, can I double click on that with you? Why has it been so hard for an industry where we have things like ChatGPT and all the advanced AI? This is a simple matter of inventory. Why do we struggle with that?
Yeah, I mean, I think it's a combination of one, it's not necessarily enjoyable. People don't enjoy doing inventory type work. So that's it had, for one, that's played a factor. But two, I think it's the evolution of the tooling, as you talked about. It's had a ways to go to get to where we needed to be in terms of providing that detailed dependency tree and graph and information around not just direct dependencies, but also transitive dependencies. We're seeing the evolution of things like software bill of materials now, where people can start to inventory and capture and store and analyze this information. But it's just taken some time as an industry to get there. And, it's amazing that it has, given the, how widely pervasive open source is, that we're just now getting a handle on this kind of thing.
Yeah, great. Oh, Aman, over to you. What jumps out at you from here?
So all of them, but what jumps out the hardest for me would be risk 7 around license and regulatory risk. And the reason behind that is there is a lot of focus on almost everything else, wherein if you do get a package with a known vulnerability, then there are mechanisms to track it, fix it, do something about it. But when it comes to license and regulatory risk, and especially for an institution like State Street, which is a GSIB, highly regulated entity, we need to make sure that we are always on top of this risk. But there isn't enough tooling that is available that actually allows us to do that. And this is something which almost falls out of purview of the developers or the CISO, wherein this is now yet another organization, which is the legal organization, which needs to look at the license of the libraries that we are bringing in, opine upon them, and make sure that anything that they depend upon, so they have honored the license risk and regulations for their own dependencies, because at the end of the day, the onus of being compliant is on the end user. So if I'm taking a library that gives me a license, but it is using another library which has a license which disallows me from using it, or if I use it, I have to expose my entire code base, then this is a massive risk that we need to stay on top of. But I don't think it gets talked about enough.
Got it. Well, thank you both. I want to kind of just wrap this up and then take a final look to see if there's any questions we haven't answered. But just from a perspective of us at Endor Labs, we are super fixated on solving a lot of the problems that we discussed here as a group today, related to better, more sustainable selection of higher quality dependencies, kind of governing that process more with automation than human intervention. How do we actually improve developer productivity, not impair it with lots of noise? So how do you actually eliminate a lot of the vulnerabilities that don't affect you, all the way to the early warning system around the maintainability behaviors of the software changing if you get significantly behind and incompatible in your releases. So I think this input is great and continues to feed into our product development process. And I want to thank you both for providing a lot of the insights on various topics from a practitioner standpoint. I think I've double checked here. I don't see any final questions. So with that, we'll wrap it up. Thanks so much, Aman and Chris, for joining us. And if somebody wants to follow up with you offline, is LinkedIn the best way for them to reach out to you with questions?
Yeah, absolutely.
Great. Awesome. Thanks everyone for listening in. Take care.